Hello everybody, hope all of you are doing fine. Today is the first tutorial for us. I will make a revision for the first sheet concerning the subject heat transfer. We will go through a quick view for the heat transfer and the solution for the first sheet. What is the meaning of heat transfer? As written, as you see, that it is the energy transfer due to temperature difference through three ways or three modes. The first mode is the conduction, convection, radiation. So what this is mean? There is a surface that contains heat, and there is a temperature difference in and out. And there are, for example, two materials close to each other. So the heat will go through a flow from one material to the other material. That's called heat transfer. When the heat is transferred or go through a quantity flow from one material to another material, from one subject to other subject, and it will make a temperature difference. So this is called heat transfer. And as we say that there is a first mode, the conduction, it's between solid materials, and we give example if you have two walls beside each other, two metal walls, and the convection is between liquids, and the radiation is the electromagnetic waves or in gases. And there is an example, if you have a pot and you put it in a flame, you will have three modes. The first mode between the fire, the heat here, the flame heat, to the metal pot, it will be, this is called radiation because it's from gases to a metal pot, so this is called radiation. And from the metal pot to the arm, it's from metal to metal, this is called conduction. And through the last mode, which is the metal pot to the liquid inside, this is called convection. So what are the parameters that affect the transfer of heat? The first parameter will be parameter will be the thermal conductivity. In case of conduction, the thermal conductivity depends on the material of the substance. If it's stainless steel, fiberglass, brick, like this copper, this is the thermal conductivity, the specifics for the metal. Okay? And also, what also will affect another thing is the area. Okay, and what also will affect the thickness of the wall. If it's 5 centimeter, 2 centimeter, 0.5, this will affect the flow of the heat. So we had a lot of equations. This is the final equation, that Q is the heat transfer rate equal K, which is a constant thermal conductivity, and it's given in all the problems. And A is the area, which means the length and the width. Okay? And there is delta T, the temperature difference in and out, when the temperature goes through the wall, through the two walls, three walls, whatever, through the construction, and comes out from the other side. And in the other case, which in between convection, here the material substances of the coefficient for the substance there for the liquid is called H, which is a coefficient of heat transfer by convection. We will find here that from the material, here is for the conduction, it's watt per meter Celsius. Here you will find it's watt per meter square Celsius. And the temperature, if we are going through the thermal conductivity, give it through Celsius, so the temperature must be in Celsius. Okay? If it's given with another parameter, we have to change it to Kelvin. And what about the wall thickness? The wall thickness must be calculated in meter. So there is another thing, analogy between heat transfer and electricity, that we said that the heat transfer equal the current, and the R thermal, that the resistance through the material is equal to the electrical resistance in electrical, and we said that temperature is equal to the volt. And we had, due to Ohm's law, that the current equal volt over resistance, so therefore we calculated that the Q, the heat transfer, equal delta T over R. The resistance are the same. The resistance, if the two materials are put in series, so the result for the resistance will be positive. We'll make a summation, direct summation. If they are in parallel, as shown in the sheet, we'll have an explanation in the sheet. It will be like this, like the electricity. So, what are the shapes for the material? As we said, it may be plane wall, cylindrical, sphere, the shape for it, the modes. So with the first sheet one, we will take through the plane wall.